Well, hello there, team, and welcome to another little update about Iceland. I'm Geology Professor Shawn Willsey. It's November 29th, Wednesday, about 10:30 Mountain Standard Time or 5:30 p.m. over in Iceland. We have a pretty short update for today, and then we'll mainly spend our time doing some Q&A. So thanks for joining me. Hope you're well and appreciate your input and encouragement and support into these updates along with the other videos I've been putting out. It's been great to just share geology with people. That's my passion. That's what I love to do. So, quick programming note. There'll probably be a few less regular Iceland updates for the next week or so, depending on the activity. So I'm not going to push these out every day if there's not a whole lot going on and not a lot to talk about. I think that makes sense. I will, however, maybe be reposting a few of my older Iceland videos from my trip in 2022 and 2023. Just I've picked up so many subscribers and there's so many new viewers, which is great, that I want to make sure people have a chance to see those. And I know you can, of course, search for those, but I just thought I'd repost some of those, maybe get some fresh eyes on them. Maybe that generates some good questions and discussion. Remember, I'll also be putting out my sort of regular content, which is just field-based videos, mainly this last bit from the Western United States. That's where I've been traveling and doing some videos over the last several months. And then possibly just to put something on your radar, I'll probably do a live stream on Wednesday, December 13th, probably at 3 p.m. Mountain Standard Time. I'll put together a little announcement so you can put that on your radar. And that live stream will consist of some possible field trip announcements for 2024, some Q&A, of course, as we normally do, and then maybe I'll share some slides and some photos of some of the places I've been traveling this last semester as part of my sabbatical and share that with you as well. So just look for those sorts of things. Let's go ahead and get to the update for today, though, in Iceland, and let's just get right to the data that we have that we can look at here. So this is the seismic data for the last 24 hours. So again, earthquakes mainly concentrated along that same northeast southwest trending zone that we believe represents the magma intrusion. That event, of course, took place, most of it anyway, around November 10th, 11th, and that's where we've been seeing a lot of the earthquakes that have been happening. So this is the last 24 hours. If we look at just maybe looking for the bigger quakes, magnitude 2 and above, we only see two that have happened over magnitude 2 in the last day. Another maybe telling way to look at the data would be to just maybe look at what the last, let's check out the last 12 hours. That's what the seismic data shows us. Last 6 hours, and then maybe just for kicks, we'll cut that in half to 3 hours. So I think if you've been with us on a lot of these updates, you can see that there's been quite a reduction in seismic activity. And I think we can see that a little bit better with some of these graphs here. Let me make this a little bit smaller. Oh, and by the way, there's been people that have been wanting me to make the cursor bigger. And so I figured out how to do that. So you can teach an old dog new tricks. And so if you push the Windows button, if you're Windows based, and then you can go to mouse pointer, and then you can change the size. You can have it be as big and obnoxious as you want to. I'll probably go with something. For today, let's go with like that size there. And heck, for kicks, let's get sassy here. Let's give it a little color. I kind of like that green color. So there you go. So hopefully now you can nicely see the mouse and the cursor. There've been a couple people that were watching it on phones or tablets or whatnot, or maybe had less than awesome vision and they had some difficulty seeing things. So this might work a little bit better. I'll make sure also that my face is not blocking anything. But what we have here is our most telling seismic station near Grindavik, and what I want to focus on is this chart right here, the real rainbow colorful one right here in the middle. And so this takes us from mid-October of this year all the way to today, November 29th. And each dot is a earthquake. And then the position on the y-axis is essentially the magnitude of the quake. Or another way to think of that is how much displacement, how much did the rock shift on either side of that fault when that little earthquake occurred. And so you can see the build up into the real ramping up here in late October. That's when we became a little bit more concerned about this part of Iceland having some sort of potential event. And you can see that continuing into November. But notice it's not a constant stream of earthquakes, right? There's lulls, there's days or windows, periods, if you will, time-wise, where things were not quite as rapid in terms of earthquake frequency and magnitude. And then we get into November, and of course, the big shift in November was right about here, November 10th. That's when the earthquake intensity, both in terms of numbers and magnitude, really started to become quite intense. A lot of the ground shaking that rattled the residents in Grindavik and the infrastructure that was damaged there. And then going into the days and weeks after that, so now we're into like mid-November, and you can see a pretty strong clustering of earthquakes, but we've lost the magnitude. The big earthquakes weren't happening as frequently. So you can see the background level of quakes is still fairly constant, but not as many of the big ones. And then we head into the last few, I guess the last week or so, and you can really see it tail off, right? Like we're not getting the big earthquakes, and we're not getting as frequent of the smaller earthquakes as well. So this shows, at least the seismic data shows things definitely slowing down, at least this past week. But of course, we can't be lulled to sleep. We know that this thing could ramp back up. But that's pretty interesting there that this last week or so, things have really subsided quite a bit in terms of the total number of quakes. Let's look at the GPS data, which provides us a little different view into what's going on. And this is mainly looking at the ground deformation. So we're going to pick the main station that's really helpful here is the one right by the power plant. And so that's this one here, SENG. And we're going to look at the bottom plot here. Well, of these three, this one right here. Let me move it just up a little bit. So there we go. It's above my head. I think that's hopefully big enough. We can maybe make it a skosh bigger if that helps. Yeah, we got space there. Why not? So this is Uplift. So now this graph is starting from late August, running through September into October. And then late October, of course, we see Uplift. So this is showing the vertical position of this specific GPS station. So the GPS station's really not moving at all. The ground's pretty stable. And then as we get into late October, we see at this location, the ground is rising, and it goes up to about 100 millimeters, about 10 centimeters, 5 inches or so. And then November 10th, which was sort of the, at least so far, the big climactic moment in this geologic event, then it drops. And the drop, we believe, was responsible for, or happened, excuse me, because of magma moving out of this region by the power plant and then moving to the east and forming that magma dike off to the east where we're seeing a lot of the earthquakes. So then the GPS data shows that the ground dropped quite a bit. It dropped, about 300 meters, excuse me, 300 millimeters or more. It's about 30 centimeters. But then since then, as we've looked at the data through the rest of November, we can see a nice steady increase in the position. So uplift, and uplift from this position to about here is about 200 millimeters, about 20 centimeters. But if you look at the last couple points here, it's maybe changing its trend. Again, that's a terrible way to interpolate data, is to look at 3 points and say, well, there's the new trend, so we're going to head off into this region here. So it's way too early to say for sure based on just a couple data points, but at least based on those and those alone, it does appear that the uplift might be slowing down a little bit. Of course, we've got this longer term trend where the uplift is pretty substantial, and so that could continue into the foreseeable future. So just, it's a wait and see thing, like the whole situation essentially, but I found that pretty interesting as well. And then finally, let's look at the Met Office update for today. So this is for November 29th. A little bit of translation language issues in here, but let's see if we can make sense of this. I think we can infer a few of the words that are not translating well into English. So possibility of an eruption remains, although the deformation and the seismicity has decreased, and that's what we just looked at with the raw data just previously. So if there is an eruption, the most likely place is east of Silingarfelt. And so that area is, we've been focusing on a little hill. I suppose we could call it a mountain, a topographic feature northeast of Grindavik called Hagafelt. And so that's here. This other one that they mentioned in the update, let me try to pronounce it again because I know people will, Silingarfelt. So I probably butchered it with the emphasis. But that location, just so you have some context here, is this hill right here. So this hill just due east of the power plant. That's not exactly where they think the eruption would be. They're saying it would be slightly east of there. So in other words, the based on the seismic data, if we were to forecast an eruption right now, which we're not, but if we had to put a spot on the map, it would most likely be this area here, northeast of Hagafeld and just east of this hill here, and very close to the Sununukur crater system that already exists on the landscape. So, okay, yeah, let's go back to that Met. Yeah, earthquake activity decreasing over the last 2 days. Seismic activity has continued to slowly decrease over the past 2 days. We saw that with the graphs. So we were seeing, remember previously, even maybe a week or so ago, I believe we were seeing upwards of almost 1,000 earthquakes over a 24-hour period, and now we're looking at things in the hundreds. So it's definitely dropped quite a bit. Most of the earthquakes are small, below 1.0 magnitude, and then the area east of the little hill there. And this is where I think the translation thing's a little bit off. But the speed of landslides, of course, I think what they're talking about is land rise, so the uplift. So the speed of uplift at Svartsengi has decreased in the last few days, but its speed is still somewhat or up to 1 centimeter per day. So they're looking, saying, hey, overall, this thing was uplifting, a lot more, even though it's decreased over the last few days. Deformation data indicates that most of the deformation is caused by inflow under Svartsengi rather than inflow into the magma tunnel. So in other words, they believe, based on their data and their modeling, that the deformation data is caused by magma coming up from deeper reservoirs or sources into this area around, underneath, or near the power plant, and it's not magma flowing out of that and over into the magma tunnel. So the expansion now overwhelms the signals at the magma tunnel, but slowly diminishes all the entries. Inflow into the magma tunnel is limited to the east, and although the deformation seismicity continue to decrease, there's still a possibility of an eruption. So there's still an eruption is still a possible outcome. I think everyone would agree that based on what we saw a few weeks ago, the chances dropped a lot over what we were seeing when we were having all the earthquakes and such. But we still have magma moving in the subsurface northeast of Grindavik. It's not moving quickly. It doesn't seem to be building at this point towards an eruptive episode in terms of moving towards the surface, but it definitely warrants caution and it warrants continued monitoring. And this scenario might go on for days, weeks, months. If you love this stuff like I do, then you just kind of sit back and just watch and see what happens, because the Earth is an amazing teacher and we can learn a lot from it. If you just like the clickbait and the headlines, then you've probably already moved on to something else, and that you're disappointed because nothing substantial happened. So, but anyway, that's my update for today. And now I want to share with you some questions that came in from some viewers, and I'll try my best to answer these as best I can. So I'm going to combine these first two together, but let me read them separately. So this first one is from my friend in Iceland, Amanda Joe, who's we want to give a shout out to because she's been generous in providing me daily updates. She sends me messages every day and lets me know what's going on in terms of headlines that I might want to be aware of. And recently it's been less science-based and more just about what's going on with the Iceland residents and of Grindavik and what's happening in the community. And so, but I do appreciate all the effort she's put into that. And she is a Grindavik resident that is displaced from her home. So we wish her the best and a good holiday season in whatever situation she's in. But her question was, can climate change cause an eruption? I thought perhaps the warming would affect volcanoes in Arctic climates. Wondered what warmer climate volcanoes would be affected by increase in heat in some way too. And then Mr. Muppet Fan had a similar question. I wonder if I can get your take on the likelihood of shrinking glaciers slash ice melt in Iceland and elsewhere. If it's increasing volcanic activity, I've come across numerous places online and find the idea intriguing. Wanted to get a pro's opinion. Well, you're getting one more opinion, which is just a drop in the opinion bucket because we all have opinions, kind of like belly buttons, I suppose. But I do have some good information here. So I did look at some papers, and I could maybe link a couple of those. Let me write myself a note to do that. Link references. Okay. So basically, so the idea here is pretty is an interesting one. When we have a period of glaciation on planet Earth, when there's more ice on the land surface across the globe, mainly in the Arctic regions and up in the mountains. That ice, as it thickens, exerts a tremendous amount of pressure on the crust beneath it. And what we see, what the data shows pretty nicely, is periods of extensive glaciation tend to coincide with decreased volcanic activity. When the ice then is melted and removed, we see volcanic activity increase. And the number I have for you here is during the last ice age, as that ice melted about 10,000 or so years ago globally. So this is taking into account all volcanoes on the planet and their eruptive histories. We see an increase in global eruptions that's about 6 times greater than during the ice age. So to say that again, as the ice melted, volcanic activity increased about 6 times over what it was doing during the Ice Age event itself. In Iceland, the number is even more pronounced. It's something like, let me get this straight because I wrote it down, 30 times more eruptions happened from 12,000 years ago to the present, which is this, deglacial period, right? We're melting the ice, where the climate is warming during the last 12,000 years. And that 30 times increase in volcanic activity is greater than the past 100,000 years. So in other words, there were 30 times more eruptions during the last 12,000 years in Iceland than there were in the previous 100,000 years. And I think that's a pretty telling data there to consider. So absolutely, can climate change cause eruptions? Sure. Basically, anytime you have pressure on the system, you can inhibit volcanic activity, and anytime you can depressurize the system, you would tend to, make sense that you would increase the amount of volcanic activity. And it could be, in this case, with a glacier. It might be with other mechanisms that we could think about, but that's the general idea there. So hopefully that makes sense, and I'll put that little reference on the video description. So okay, so from this person here, is it truly a disaster? Yes, there have been economic and infrastructure damage. Yes, people have left homes, but they are safe, warm, fed, and able to get education. However, there's been no loss of life, no injuries. So what constitutes it being a disaster? Should it be termed differently to disaster? And that's a great question. When I teach my natural disasters class, the way we define disaster, and I think this is what you might see in a lot of textbooks or maybe even in the dictionary, a natural disaster is typically a natural event in which it affects humanity in an adverse way. Usually that is defined as being significant economic damage or significant economic impact, and or fatalities or injuries. So whenever you get one or both of those, that passes the threshold of what we typically think of as a natural disaster. Anything besides that is just a natural event. So if a volcano erupts on an uninhabited island in Alaska in the Aleutians, and produces pyroclastic flows, and maybe a lot of the forest is decimated, maybe it has a big impact on wildlife, but no one's property was at risk, it doesn't shut down air traffic or affect humans in any adverse way, then that was a natural event, but it wasn't a disaster. And then on the other hand, you could have something that was less powerful, less of a big to-do, if you will, kind of like the thing in Iceland in a way, right? We haven't even had the volcano, there's not even a volcanic eruption. What we have had is and earthquakes. We've had a lot of earthquakes, and we've had some subsidence, some sinking of the ground, and that's what's caused some of um, the damage there. I would argue that absolutely this event in Iceland is absolutely crosses the threshold of what I would call a natural disaster. It's affected 10% of, or 1%, excuse me, of the country's population. People have been displaced. It's having a marked economic impact on the community, loss of tourism revenue, the impact to the fishing industry, and probably some other things I can't think about right now. So absolutely, it could be considered a natural disaster. But I do see their point. So the good news is it's maybe, I guess, the if you're going to have a natural disaster, maybe this is the best kind to have in a way because no one's been hurt. Everyone still has a place to be and live. And I think that's a good, I think that's as much a tip of the hat to the Iceland community and people as it is to anything else. So, but interesting question. I appreciate that. From Curtis Lund, would the amount of pressure that a body of magma is under also affect how molten it is? Could an event that dropped the pressure re-liquefy the magma? Yeah, so pressure is important in, it doesn't really, yes, it does impact how molten it is. If you depressurize the system, you are going to get more of the gases expanding, those dissolved gases expanding. That's going to cause the overall body of magma to become more buoyant and less dense and want to rise towards the surface. It may not affect, well, at depth, it does affect how molten it is too. So absolutely, pressure is um, a huge factor in how molten the magma is. So, yeah, good question there, Curtis. Hopefully that was a good enough answer for you. From Solar Wizzo, I guess Rudy in New Mexico. Minute 10 of your video. And to be clear, I pulled these questions mainly from the last two updates. So that would be this past Monday, the 27th, and the previous Friday, the 24th. So I'm not sure which video this came from. But anyway, in your video, you discussed the uplift, sudden drop, and then uplift again. Could that be the result of normal rift zone mechanisms? I mean, spreading of the land at tectonic plate boundaries without eruption, meaning a mechanism which allows spreading of land without volcanic eruption, equilibrium of below ground pressure with above laying land masses, easier to push rocks sideways and fight gravity upwards. Okay, so kind of a lot of questions embedded in there, but I think the idea is that Rudy here is asking is um, we've got a couple things going on, right? We're on a plate boundary or a rift zone system. So it's a divergent plate boundary. The plates are spreading apart. And really, I think when we get back to what started all this thing in late October, it appears as it's not as much magma pushing its way up and forcing the land apart, but because the plates are moving, we have that extension, we have that stretching of the crust that's already taking place, and that depressurization on the layers below allows the magma to one get generated and two it gives it a pathway to come up towards the surface. So to answer the question, yeah, absolutely. So a lot of the movement we're seeing vertically could be partially related to the opening of the land in with this plate boundary. But realize that the plate boundary it doesn't move, 30 meters apart in like a split second. That the average rate of plate motion here in Iceland is like a centimeter per year. So it's slow overall. You can have more than that in a given period. But I think he's asking more, could it be tectonic more than volcanic? And I think it probably is. I think it's more tectonic than volcanic. The volcanic activity is following the volcanic activity is following the tectonic activity. Yeah, so it's sort of the dog with the tail little analogy there. Timothy, say there isn't an eruption. Does this event affect the likelihood of a future magma intrusion, long-term instability, or eruption? Could the magma close to the surface? Oh, close. Could the magma close to the surface cap the magma plume, affecting the dynamics further down? Sure. So, that magma that's moved up and got within, let's say, 500 meters or so of the surface, if that completely cools and crystallizes, that rock now, which has cooled underground and is probably much more dense than the volcanic rock that surrounds it, that is older rock that erupted from previous eruptions. Um, that being said, so that would present a, he's calling it a cap, and that works for me. Let's call it an inhibiting layer, I suppose, or a body of rock that's more dense. But what we would have in the future, though, is the magma is going to find its way upward if it has the right pressure, right? Like if it has the buoyancy and the pressure, it's going to find its way to the surface. Maybe not through the path that cooled and solidified, if that's what takes place, but it's going to find some other path, and that might be a kilometer away. It could be 100 meters away. Just depends on exactly the plumbing systems that have been created. Every earthquake in Iceland, every intrusion of magma, it's constantly changing the network of fractures and voids and spaces that the magma can intrude and move into. And so it's a constantly changing equation as to exactly where that future eruption might take place. So hopefully that was a good answer for you. Jacques, so which of these leads to a quicker return to normalcy for the residents of Grindavik? An eruption north in the Hagafelt region, or a low level of activity, say what we saw for the better part of the last few days, that doesn't seem to decrease significantly with occasional upticks? Yeah, that's really a deep, meaty question. Um, which one gets you back to normal? You could make a good argument that having the eruption is better in some respects. Now I don't now obviously if we could somehow magically have the eruption but spare any damage to infrastructure or minimize that, which would be hard to guarantee at this point, that would be really like the the, the goal, right? Um, yeah, because then you'd at least have the eruption. You'd probably see everything drop back down, and at least for, I mean, what we've seen in the region, it's probably will only last a few months. You're likely to see whether this thing erupts or doesn't erupt in the next few weeks or so. You're likely to see a repeat event or a similar event within the next couple of years, right? And so, but in terms of just getting them back to normalcy, I don't think Grindavik is going back to pre October 2023 normal anytime soon. I think we're going to have to adjust to a new normal in that region. And the new normal might be, okay, we've prepared the infrastructure, people are back in their homes, but we've got a heightened sense of risk in the area. We've got maybe a better alert system. We're going to monitor this thing much more closely. And it might be a situation where, yeah, on occasion they have to evacuate because there's some unrest, and then they have to kind of wait and see, and then they might be able to come back in. And I don't think the old normal is on the table, at least in the short term. So, good question there, and that's a tough one. That's the one that maybe no one wanted to ask, but it's worth exploring. And that's what the public officials are, I'm sure, wrestling with. From JF Mezzi, does ground inflation mean that magma is being pushed up with nowhere to go? Does pressure need to inflate ground? Is pressure needed to inflate ground increase as inflation progresses, or is it pretty much the same pressure needed to be exerted by magma to raise ground, whether during the first 10 centimeters or the next 10 centimeters? Um, so let's be careful here. We can measure ground, elevate the movement of the ground, right? The ground was here yesterday, today it's here. So we can measure that. We interpret that, especially in this sense, to be caused by magma inflation. But remember that we've also, you're also heating the rocks as well. So if you've got magma that's moved into these rocks that were previously not as hot, then as you heat up those rocks, that's thermal expansion of those rocks. You'd expect that to cause the ground to swell a little bit as well. Um, then there's the question of like the gases in the magma and how close it all is to the surface. So there's lots of other things going on there. Um, but ground inflation would mean that the magma has moved into some area it is causing the land to rise partially due to pressure and partially due to thermal buoyancy or expansion. Um, yeah, and I'm trying to read the second part of the question. Does pressure needed to inflate the ground increase as inflation progresses? I mean, I don't know the physics of it offhand, but yeah, you need more. You need it's a heat pressure buoyancy game that you're playing here, and so you've got to, if it's hotter magma, you're going to see more inflation than if it was a cooler magma body. If it's magma with more dissolved gases in it and it's close to the surface and it's exerting more pressure, or if the inflow rate is greater, then you'd expect that to go with the inflation rate or a land uh, uplift that would go quicker with it as well. So, okay, hopefully that was a decent stab at it. So, worth what you paid for it, right? Trish Murphy, if the quakes are 5 kilometers depth, how is that related to the magma being 500 meters or so? I thought the magma intrusion was causing the quakes. I have clearly misunderstood, so could you clarify? I think what this person's asking is, remember at the height of this whole thing, we thought we had the best data suggested that the magma was as shallow as 500 meters, half a kilometer. And now what we're seeing is the bulk of the quakes around 5 kilometers in depth. But really, I mean, that's where we think the sill is. So the main magma body is at 5 kilometers depth. And then we think it moved into the dike, moved up, and you can go back to those silly diagrams I drew that might help a little bit with this. And that the head of that dike, the upward propagating head of that dike, got to within 500 meters. But if you look at the quakes themselves, even if we look at today's quakes, and you can see this, whoops, on the list over here to the right, if you look at all the numbers there on that table, the third column over is depth. And you can see, even though a lot of them are around that 4 to 5 range, there's plenty that are shallower. Here's an earthquake from the last 24 hours that's about a kilometer down. So it's shallower, right? And it's right by the town. Here's one here that's, well, that one's 5, right? So let's see, here's a bigger one here. That one's about 6. That one's 4.7, 5. So a lot of the 5s, right? But I guess what I'm saying is if you started scrolling through a lot of these, you might find a few that are at different depths. There's a deeper one at 6, 3.2, 2.9. So what that means is the quakes are forming where the rocks are breaking. The rocks are breaking because the magma has been injected into the system. It's changed the stress conditions in many places. There's one that's a little bit deeper. Yeah, so there's a few that are shallower and a few that are deeper, but yeah, most of them are in that 5 range because that's where we think the main magma body is. Um, yeah, so the quakes, so the magma got to within 500 meters, and now what we're seeing is rocks. So now as more magma being pumped into the system, some of those rocks are adjusting to the temperatures. Some of the quakes could also be, this is interesting to think about. We talked about in our last update about the magma solidifying and cooling. And that would generate quakes as well. If you're going to have the magma body start to cool, that's changing the stress conditions as well. Now, instead of everything expanding, it's sort of collapsing, and those little stresses could generate some of these tiny earthquakes as well. Um, yeah, so the quakes are related to the magma, but the quakes don't have to be at the same depth that the magma body is. The quakes can be below the magma body, to the sides spatially, above it. But you would expect that most of the quakes would be where the main stress is, which would be the magma itself. Meredith and Sierra took a look at the link. Let's see. What do the people of Iceland understand about their country being torn apart along 2 tectonic plates, and are they scared? Well, I can't speak for the people in Iceland, but I will say, having been there a few times, that they are proud of their country. Most of them are very well educated and know a lot about its geologic history. They're not necessarily geologists per se, but they fully realize that they are on a volcanic island in the middle of the North Atlantic that also is a plate boundary. They fully understand that their country exists because of those geologic processes. They fully understand that all the beautiful and scenic marvels and wonders that millions of tourists come to see owe their existence to those geologic processes. So I would say, I'm not speaking for them, but my sense would be, um, do they understand? What do they understand about their country being torn apart? But they understand that's how their land formed. Was that this divergent plate boundary gave them this beautiful country that they love. Are they scared? I don't think they're scared. I think they're aware. I think they are problem solving people that are going to look for ways to continue to dwell and live with the risks in their area as best they can. It's really no different than, I mean, we could go to, I mean, this is, you can do this anywhere, right? Let's do a thought experiment here, and let's go to a mobile home community in Kansas and knock on the doors of those people and ask them, what do they understand about their community lying in a region that has frequent and destructive tornadoes, and are they scared? Or let's go to the coast of Florida and ask those people in those communities, what do they understand about hurricanes and tropical storms, and are they scared? Or let's go to Southern California. I mean, so any place you go to, for the most part, has one or several natural hazards that exist. Could be landslides, wildfires, tornadoes, hurricanes, earthquakes, volcanoes, whatever. Um, it's all about being knowledgeable about the risk, um, understanding the risk, and then mitigating the risk. I'm going to be proactive about what kind of home I build in Kansas, or where I live on the coast in Florida, or where I live in Iceland. I'm going to be proactive about, um, you know, paying attention to scientific reports and public officials, and being proactive rather than reactive to those threats as they emerge. So, yeah, great question, Meredith. And I'm sure maybe we'll get some comments from the Icelandic people here. They can answer that directly. But there's my 2 cents on it. So thanks for your question. Hell for 2217. Could the decrease in activity since the emergence of the dike come from the fact that the space in the dike first have to get filled up? Yeah, absolutely. Right. So we saw that magma move over into the dike, and now we've seen everything kind of drop off. And that's because the magma was pushing up underneath the power plant, but then it found its way, or forced its way over, and created a dike from the town up to the northeast. And now we're seeing things die down because that magma moved over there and is presumably cooling a little bit. And now we've got more magma coming up. And the big question going forward is that magma going to reoccupy and push its way back into the dike, or is it going to go somewhere else? Is the amount of magma inflow going to dissipate? All good questions that I don't think we can answer right at this point. Oh boy, here's a long one. This is our last one though, team. So if you're still with me, that's awesome. Lost in blank. Okay, this is a long one, but I think there was a reason I put it all in here, because I thought it had some really good points. So assuming Grindavik makes it to March 2024 intact, so let's say, a couple more months, should new construction and population growth be allowed in Grindavik? So good question. Like, what would you do if you were prime minister of the country, or one of the elected public officials that was charged with this? Would you approve a new subdivision of homes in town? Would you allow people to move there? Or has enough happened already that Grindavik should be stabilized at its current population and any growth delayed until 3 or 4 decades from now? It's very hard to judge acceptable risk in another place and another culture. Look at the cities in the US and Canada that are located on the floodplains of rivers. Excellent point. I mean, it's no different. It's just a different threat and different hazard. The alternatives are: one, government continuing to facilitate and even drive more population growth in Grindavik. Two, banning population growth. So basically, you could say, hey, there's no more building. You cannot build a home here. No more infrastructure until things stabilize, for however long that could be. Government incentivizing people to move away for the next few decades. That could take place. You could, say, hey, this is, kind of a rough place down here in Grindavik. If you move away, then we'll give you credit, or something that helps you make that transition. And then four, government ordering an evacuation that lasts decades. I think this is the least likely, unless the geologic unrest is of such a risky level that it warrants that. I'm just a Canadian person living in a city on the floodplain of the Red River. My guess is that Icelandic politicians would be offered options one and two by their technical experts. Is that right? In the end, it would be a political decision, not just engineering and geology. Yeah, absolutely. So in the end, it's the science. It can just say, hey, here's what we know. Here's our estimates. Here's our best projections. But it's almost never clear cut. It's never, oh, the volcano is going to erupt undoubtedly in 2 weeks. We never get to that level of certainty, and that's why it makes those decisions when you're dealing with people's lives and livelihoods so tricky. Whose fortunes we made or lost? Is there anywhere in Iceland with much better geology, or is Grindavik pretty much typical and we've got to live with it? There's definitely, I'd say, I wouldn't say safer is the right word, but there's less hazardous zones in Iceland. Like up here in the West Fjords, like this area has seen its volcanic activity pretty much come and go. So but there's other hazards here, right? There could be like landslide hazards or other hazards here as well. Um, but yeah, like anything on. I mean, we've got the airport here. We've got the capital city close to this peninsula with these volcanic zones. Um, yeah. So are there now? If you settled Iceland now and you had all the geologic data at your disposal, would you set it up differently and ask people to live and set aside maybe communities and zones that are quote unquote safer or less risky, and then ask those populations to grow over time and maybe keep people away from the more risky zones? Sure, but I mean that's the case in any country. We didn't settle Most countries weren't settled that way. We just got there and we looked for the resources. There's good fishing here, and that's why what I've learned about Grindavik is it's there because of the harbor, right? There's this protected embayment that allows the boats to get their go out and go fishing, then come back into harbor and stay out of the heavy surf and the waves. But it's ironic because the bay's there because there was a lava flow over here and there was lava flows over here, and it just fortuitously made this little bay, and then people ended up kind of settling there. So um, yeah, it's interesting. I think I got to most of the parts of the question. So political decision in the end, but what options would geologists and geotechnicals recommend the Icelandic government consider? Yeah, it's a sticky wicket. I mean, it's in our human nature in most of these situations, and we could look at case studies across the globe, whether it's in the US or other countries, where we settle an area, we have a sense of community, like the people here are proud of their community and their town, and it goes against our human nature to some degree to completely just say, well, it's all lost, it's too risky, and we're just gonna have to live somewhere else. We tend to want to like stay there, right? What are they doing right now? They're putting up berms, and uh, they're putting in some infrastructure that would hopefully protect not just the power plant, but also the town from possible lava flows that may happen in the future. And so I think no matter what country we're talking about, it's part of our DNA, I suppose, that's the way humans are. We're fighters. We want to stay, we want to maintain what we have, and even with all the data in front of us that maybe suggests otherwise, we'll try that. So I think the Icelandic people, the no eruption has happened yet, and yes, we could be looking at a 500-year period of future events, but for right now, if you could get another 30, 40, 50 years out of this community, why wouldn't you? Right? But at some point it can become maybe cost prohibitive and it just doesn't make sense logically. So it's tricky. That's a good question. These are like, these are great these would be good ones to give to students on like an essay or something, right? Like a debate, pros and cons, something like that. So anyway, Awesome stuff. Thanks so much for your questions. I appreciate them. So that'll wrap us up for this time. Thanks for all your support and encouragement. I do appreciate it. You can look for a couple more videos coming out this weekend from some of my travels in Wyoming around Devil's Tower. So if you're interested in Devil's Tower, look for those. Otherwise, the next Iceland update, if nothing happens significantly, it would probably be the week of the 11th, or maybe around the 8th or 9th. I should be back by the 8th, which is Friday, a week from this Friday. Otherwise, I'll be down in Southern California, working on some more geology videos down around the San Andreas Fault, Salton Sea area. There's some great stuff to go look at down there. So appreciate all that you've done to support the channel. Please continue to do so. I love getting geology out there to the masses. That's my passion in life. But hope you're well. Stay well. We'll hope for the best in Iceland and take care. Thanks so much.